Yeah, yeah. It's kind of flowing right now. It wasn't when I arrived, but now it's flowing. It's flowing down and it's flowing horizontally too. But in our context, what is flow? Yeah, processes that flow from typically left to right, like this. I'm going to show you an example of flow that I just saw outside here. So for example, here's a traffic simulation, but it's kind of a metaphor of the project we're in. So ideas come in at the top, and then some refinement happens, and we design things, and then architecture happens, and uh, upfront design, and then development and maintenance, and then it goes to production, right? And every one of these cars is like a metaphor for a user story, a use case, whatever you do. And then you have to watch out for this zone here. The simulation will probably cause some problems there. There you go, it slows down, there you go, right? So one truck caused this, and so there's slow down here. And on the work floor, we know there is a problem. We already know it right now. Management doesn't know it yet, right? The product owner, no idea right now. And everything fills up and slow downs, and everything, nothing gets delivered anymore. And now we have meetings. We have to speed up. And like this simulation is projected right here, this will never be solved. This is now the steady state and it will never change. There will be some speed ups and intermittent speed ups, but then halts again. And because the inflow up there and back there where the bugs come back from production is just continuously flowing into the system and nothing gets solved. So I can keep this like hours and it will never be solved. We're going to try to solve this by doing things with our projects. So I'd like you to get out your mobile phones. I need 5 participants to play. First of all, I'm going to explain what's going to happen. We're going to do a simulation of a project, just like this one. And the people with a mobile phone will have to work. So just to give you an idea, this is the board we're going to work on. Someone is going to work on to-dos, that's probably the product owner. Someone's going to do some analysis, development, ops, and then QA. And so to give you an example of what the tasks will be, I'm going to start an iteration. The product owner, the easiest job is just hitting a button, create task. That's it. So it just appears there. It appears on the board, right? Then the person doing the analysis is going to see something appear in their inbox, is going to open it, and has to solve a simple task, copy the number, right? So we do 9, there you go. Then development sees something appearing in their inbox. Okay, help me out there. 88? Oops. 88. There you go. Then ops is going to see that task coming in. This is easy, right? Ops is easy. And then QA sees something entering, and the system will tell QA if it's okay or not, but they can still choose to reject or accept. Just like in normal life, right? And so I would advise the QA person to click accept here, because otherwise the simulation will go very wrong. So now I'd like to know, you've seen these tasks, right? The product owner hits a button, the analyst just copies a number, developer has to do a small calculation, operations has to do also a calculation that's typically a bit easier, and then QA accepts or rejects. How long do you think it will take? So I'd like to have an estimate in seconds for a card to go from left to right. 40 seconds, all right. 50 seconds. 30 seconds. 80? Just on average, a card. So this is what we call lead time. Whoops, time. So it depends is an answer for every consultant, right? But there's a trick on the it depends thing. If your rate is very high, you can go like, I think it depends, right? That you take time to say it depends. But jokes aside. We're going to do simulations of 2 minutes. How many cards are we going to finish in 2 minutes? Or let's just go for cards per minute. 1, 10, 100? What do you think? 1 per minute. So there's 5 people working parallel. So this one can just go tick, 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 right? And then it goes through the system. 10, 5. This is what we call throughput in items, let's say, per minute. So this is just to have a feeling of we're going to estimate based on what we see, and then we're going to verify if the time it takes to finish something corresponds to what we feel. So let's finish this one. This can go on, right? We're going to make a new simulation, and this is where you come in. The first 5 people who scan this will participate. Okay, we've got a product owner already. Analysis, development, ops, and QA. Too late, so we've got 5 people. Okay, so we're going to iterate 2 minutes and just work as fast as you can, right? I don't know who is the product owner, analysts, and so on. We'll just see what happens. But you work as fast as you can, right? Try to get the quality up, so don't make any calculation mistakes, because, of course, those stories will be rejected and you don't win anything from it. Ready? Go. So someone is doing nothing right now. I have the impression that the product owner is not working as hard as he could. So the product owner, I'm not sure who it is, work as hard as you can, right? Hit that button. Who's the product owner? Who's the one doing the to-dos, the first column? Here? You have to work, right? Hit the button continuously. Oh, there you go. Or analysts. There's 2 bottlenecks, right? Oh, we have a defect. Watch it. A few seconds left, come on. That's it. Simulation's done. So, what do we see? Just the board. Don't try to understand the numbers yet. A lot of to-dos, right? Right. So, how do you know? So, a bottleneck, you can recognize a bottleneck by looking one column before it. If it's a large number of items, this is a bottleneck. But you have that here too, right? There's two bottlenecks. We don't know where the real bottleneck is right now because we just don't know, right? So, how did it feel for the developer? Let's look at the developer. Stressful, right? Is this you? Okay. That yeah, QA knows. QA rejected for one reason. Don't know. Yeah. Right. So, why was it stressful? Yes, because you saw this, right? And the challenge was hard, right? Sometimes it's easy, but mostly it's kind of, you have to calculate things. How did it feel for the analysis? Yeah. Yeah. How did it feel here? Ops? Yeah, probably. Yeah. Two tickets waiting in line. Mm. Okay. So we see here throughput and lead time. Do you have any idea what the units are? So throughput is 8 cards per minute. So this should be 16. So 4, 4, 4, 4, 16. Because we did 2 minutes iterations. What is this lead time? Yes. Yes. How much is it? No. 4.6 minutes. Minutes, not seconds. Why? Yeah, exactly. Because you have to predict how long it will take to finish everything on the board. And so if I put one ticket in now, it will be more than 4.6 because it has to wait for everything to finish before it gets finished. So it's 4 minutes. I'm going to expand this part. So we have one defect, 17, total 16, yes. And then the work in progress, so how many cards are in progress, is 36, or 37. And so there's a very easy formula. If you take the lead time times the throughput, you get the work in progress. It's called Little's Law. I'm going to show you that later on. This is something that always works in a stable system. This wasn't a stable system. What is a stable system? It's a system where the number of items coming in per unit of time is the same speed as the number of items leaving the system per unit of time. This wasn't the case here because the input was much steeper than the output. And I'm going to show that in the chart. This is what we call a cumulative flow diagram. So the red line is the input, the product owner hitting the button. And you see in the beginning, it was slacking, right? It's horizontal. And then speed went up, and then I said, you have to push more, right? And then the speed went even more up, right? And then this gray one, that's the defect. And the blue one is the speed at which items appeared in this column. And so you can see that it kind of fans out, right? This will never be solved. The system will get worse every time. Every time there's a new card in the system, it will get worse. And waiting times, lead times, will get worse and worse. And the throughput is the slope of the blue-purple line there on the right. How do we solve this? More developers, yes, but the simulation doesn't allow that. Sorry. We'll get to that later today, but not now. You can control the amount of to-dos, yes. So what we're going to do now is let's look at analysis, for example. When you're working on analysis, you're not allowed to have more than 4 items in total in your workspace and your outbox together. So you add this number, and that's 4 maximum. And that's for everyone, every post here. So to do, you're not allowed to have more than 4 items in the outbox. Once someone takes an item out of the outbox, you're allowed to add 1, right? So we limit our work in progress to 4 per skill set. Of course, QA is allowed to have more in their done box, because otherwise, right? So that's the exception. Is that clear to everyone? Same people, or you might switch around if you want to, but if you change one variable, it will be clearer what the effect is, right? Okay, so 4 items maximum, workspace and outbox added together. Clear? Okay, go. Warcraft. So for the people observing, you see things happening now, right? Analysis is doing too much work, right? 5 items here. So now you have to wait as an analyst. No. They're just choosing to limit, and I'm checking that they do. Yes. Oh. Oh, still 5. Oh, there you go. And it's done. So what did you see? What happened? More tickets. So we did 18 tickets instead of 16. But that's because we're getting used to the system. It's not because of the organization. It's not the WIP limit. But the throughput, the throughput stays almost the same. But the lead time, yes, is improved 4 times, which is already quite good, right? We're going to make it better, but it's already good enough. Where's the bottleneck? Looks like it's analysis, which is strange, right? Because this task is so much easier than that task. So lead time 1.1. Okay, another one. Look at the graph. The in-stream and the out-stream go parallel. There's no fan out anymore. This is a stable system compared to the previous one. I went like this, right? This is an increase in predictability. So your predictions, if you start at something, you can say, we'll have a lead time of 1.1. In this case, it's minutes. It's still a lot, right? If I compare that to what we predicted. There's one that was pessimistic. The rest was below the actual number. Okay, how can we improve the system even more? Any ideas? Improve the people. That's always a good thing. Absolutely. I, I would prefer to hear we're going to train our people instead of replacing them with better people. But it's an alternative, that's right. So what we're going to do is we're going to try not to limit each skill set, work in progress, but we're going to limit the work in progress overall. So I'm going to ask the product owner to watch the yellow number there, that's 37 in the first iteration, 10 in the second. I'd like it to keep maximum 8, not more than 8. I'm not sure anymore. There he is. So clear to you? The yellow line, the WIP, work in progress line. So you 1, 2, 3, 4, 5, 6, 7, and 8 are allowed. 9 is not. Right? No, no, the rest just works. Oh, by the way, the analyst. Who was the analyst? You were tempted to work harder, right? You had to wait. How did that feel? But in your real job, would you accept? There's a WIP limit. I finished my job and I cannot start anything new. But I asked you to do nothing, right? And still the numbers increased. Let's do the simulation. So product owner, 8 things at the same time. So you have to watch the board and the rest can just watch their phones. Yes, exactly. Yes, just as fast as you can, whatever. Ready? Go. Oh, we got a defect again. We're not. We're throwing them away. Oh, it's done. So, 2 defects. Yes, right. But even with 2 defects, in total we did 22 items. So in total, we improved our throughput and our lead time. Again, throughput is accidental. If we would do the first simulation or first iteration again, the throughput will be higher too, because we're getting used to the system, right? Maybe the defects will go up. We don't know. But the lead time improved even more, right? Now it's 0.7 minutes to do your job completely. So a nice thing about this diagram here is that the lead time is the horizontal distance between the red line and the purple one. So each item that gets added to the system will be delivered horizontally when it reaches the purple line. That's, by the way, why in the beginning, the top red one, the last one we delivered, will be delivered when it reaches the purple line, which is somewhere there. That's why the lead time was so high, right? So coming back to this, the work in progress is the vertical distance between red and blue. So lead time and work in progress can just be read into this diagram. Yes? Yes. Because somewhere in the system, something was blocked, and the work in progress was 8, and so the product owner was not allowed to add things. So yes, and it was between yellow and green, so that would be ops. Four times 9, yeah, right. That's a hard one. So you're allowed to pair if you want to. We could, but if we look at the board now, where's the bottleneck? We stop at an awkward moment, but there was typically a longer list here. This is the bottleneck. And we only know it now because we limit work in progress that much. Yes? It's development that's the bottleneck. Because you recognize a bottleneck by how much things are waiting before it. So this is the actual bottleneck. This is what is taking time. Yeah. Yes. So development is the bottleneck. It's the thing that slows everything down. If you manage to increase the speed of development, the whole system will speed up. Because that's what a bottleneck is. If you improve the bottleneck, the whole system goes faster. There's no need to go faster than the bottleneck. And that's what we're trying to artificially cause by limiting work in progress. So I'm going to try one more thing, which is called the drum buffer rope. I'm going to explain that. So let's say there's a marching band, right? Marching from left to right. And in front, there's this cute little girl with a stick, right? That moves forward. And then halfway, there's the drum. That's like the big thing. And it goes like boom, boom. Well, that's a small one, but not that. And typically, if you're carrying something heavy, you're going slower. And so you have to imagine that if everyone goes at their own natural speed, the drum will go slower and everyone will pile up behind him. And the front of the marching band will like stretch out. And so to cause the marching band to keep at the same speed, you have to imagine a rope, the drum buffer rope, between the drum and the person in front. So the person in front cannot go faster than the drum. That's what we're going to simulate now. And so I'm going to ask the product owner to not go faster than development, but just look at development. So keep this column filled with at least one story. That's it. If there's one story, you can add a second one, but don't fill it up and don't let it get empty, because if development has nothing to do, the whole system slows down. So development has to work at 100%, but not have too much here. It is going to be challenging because there's a delay between your action and the task coming here. But that's part of the game. That's it, and the rest just works as hard as they want. Excuse me? Just like real life, except the product owner shows restraint. That's the difference. Yes. Right. Ready? Oh, QA is not awake. That's okay. We have to wait for QA to appear. There he is. Ready? Go. It's the first time I've done that with music. Mm. Good work. Smooth, yes. So this is what I would call flow. And by the way, no defects yet. I might have jinxed it. Yes. Doesn't happen, right? In real life? Never happens. Exactly. QA is so good that they always reject bad ones. And the simulation's done. So, a board that's almost completely empty, right? If management comes around now, they will say, "What are you guys doing?" Right? But the numbers are spectacular, right? So, limiting work in progress had almost no effect on throughput, but the lead time compared to the first one, almost 5 minutes to almost half a minute, that's like spectacular for the same work, right? The work didn't change. So that's an improvement of, someone can calculate that, the developer. 10x? So we made 10x developers. Isn't that great? Just by limiting work in progress. Yes. Yeah. What about the stress levels? Last one was best. Yes. It's a simulation, of course, but having to pay attention to doing the work and also counting what's my personal work in progress, I understand it's even more stressful. Mhm. So lead time. Why is lead time important? Um, have you ever been in a project where the business asks for something, and then months later it goes like, "What are you guys doing? This wasn't so hard. Why is it not finished yet?" That's lead time, right? They ask for one thing and it's not done yet, and they see that you have a speed so your throughput is kind of okay, and that's what we all only measure in Scrum, right? Velocity is throughput. We only measure velocity, and all these simulations have very similar velocities, throughputs. And so people aren't aware of the fact that things slow down in the system by being in the system for too long. And so lead time is another measurement of so flow measurement that is very important to measure your effectiveness. So for example, if you treat the whole backlog as we have to make all this, then it doesn't matter. At the end, you will finish at a certain date, right? But if, however, you say these are hypotheses, and I'm going to make the first one and finish it, and then based on what my user says, evaluate what I'm going to make and what I'm going to throw out and eventually choose different things, then the lead time becomes important. Because then you can iterate over your product and improve it while you're building it, and not just saying this is a static list that has to be finished one day. That's why it's important. So throughput, the team and the kind of work will define the throughput. But lead time is absolutely a process thing that you can, it's a lever you can tweak. This is how far I want to go with the simulation. I want to do a small recap and then we'll have a break. So what we did is push-based work without limits, just the one in front pushes work, right? Then we did pull-based with local limits. So pulling is, I'm here and I take work from my right side, your left side. And then that frees up a slot there that makes them work, and that frees up a slot there that makes them work. And this is called a pull-based system. Then we did the same thing with the system-wide WIP limits of 8, I think we choose. Then we did the drum buffer rope, and this is all an illustration of Little's law that I said was, I said out loud that lead time times throughput is work in progress, but that's math, right? You can put that there and it's same formula. But it's always applicable in a stable system. And so this is something you have no control over. The work will define, and the work and the team composition and things like that will define what your throughput is. If you want to improve lead time, you have to lower your work in progress. But not too low, right? Too low is the bottleneck has no work. If development in our system would have like a pause of 10 seconds, the whole system will have a pause of 10 seconds and you will lose time. So it's a question of looking for that balance of what is the right work in progress limit you can apply. Right, and we'll have a... Okay, let's do the question. No, it's in context. Priorities in the city. But so you're saying, what if priorities, that for me, it's just work for the product owner. The product owner has like an idea of things that have to be built, and the highest priority is the one that's going to enter the sprint backlog. The first column is going to be that, the highest priorities. That's dangerous. It's possible. So for example, there's a production issue. Drop everything, we work on the highest priority, it's the production issue. That means that all the rest has a lead time that increases. So all the rest is going to wait and it's going to cost money. But I would always advise to do the production issues and even the bugs first, because that is a cost in itself, like prioritizing bugs and negotiating what's the most important one and so on. No, just do them as they come in. Stop everything, fix the bugs. Once there's no bugs coming in, you continue with your actual work. That's my advice. I know there's opposing opinions. Just throwing that out. And then now we have a break.
everyone. We're going to start again with round number 2.
All right. Who knows the 4 rules of simple design? No. So the 4 rules of simple design is something from Kent Beck that was popularized. Kent Beck? Everyone knows Kent Beck, of course. Extreme programming, test-driven development, pair programming, things like that. Kent Beck. So the 4 rules of simple design are in a certain order. So the first thing you have to do is it works. So your system should work. That's the first thing you have to validate. In extreme programming, that means the tests are green, right? We all do test-driven development, right? Cool. The second and the third, there's some discussions, but I tend to favor the code is intention revealing. You can read what it's doing in the code. And then one below there is no duplication. And then below that is as small as possible. So not too many moving parts. So that means that if you have to choose between duplication and intention revealing, you go for intention revealing and you add duplication. So there's an order, right? Why am I telling this? Because I realized that I have duplication in my slides. That's it. That's the joke I want to start with. Thank you. I'm not going to give up my day job, right? For stand-up comedy. Thank you. So I'm going to accelerate now. No need for mobile phones anymore. You can fall asleep, do whatever you want. I'm going to do a simulation of a developer working with the same metrics. So throughput, lead time, work in progress, and also time worked in days this time. So every story here takes exactly 1 day to finish. So throughput is 1 story per day. Lead time is every story waits exactly 1 day to be finished. And that's what I show here. You see the cumulative flow diagram that goes at the same slope, at the same speed, everything. Nothing is unpredictable here. So here, there's something strange going on here, but it's okay. So the developer works exactly 1 day on each story. And so finishing 50 stories should take how long? Maybe 50 days, but you have to count the startup in the beginning, so it might be 51. We'll see. 48, 49, 50, it's 50. There you go. So throughput of 0.99, because in the first day there was nothing finished until the last minute, the last second of the first day. But lead time exactly 1. So if I add a variability to the system, so every story is on average 1 day of work, what do you think the numbers will show? The same? Worse? Lead time will increase? Let's see. There you go. So you see, lead time and throughput are kind of mirrors, like the formula predicted, right? Lead time times throughput is work in progress. Now you see that formula in action. it's not exactly in action, it's not exactly mirroring, because lead time is something you measure when it's done, and throughput, you measure every unit of time. So if you work for 2 days and there's nothing being delivered, throughput is 0 at that moment. So the measurement is slightly different. But on average, it mirrors, and you can see it. And here you can see, it's kind of visible. The yellow lines are the moments where work in progress is 0, where this is empty. And so you can measure how long a story took by seeing how far apart these lines are. This was a long story, this was a very short one. Does that make sense? Kind of? Okay. So this was just to prime the system and to explain how it works. So we're going to add the QA to this one. And now there's a developer in the team, and there's a QA person in the team. And every work item has 1 day of development and 1 day of QA. So on average, 2 days of work. Oh, there you go. And so now there's a backlog of 50 items. Development is working, putting in the done column, where it sometimes has to wait for QA to pick it up and put it into the done column. There is always going to be items here. And on average, it's 1 day here, 1 day there. Why is there always an item here? How come? The law of averages. So beware of averages, average velocity, for example. Plans based on average fail on average, right? So what happens here, if QA is faster, this is empty. Once development is faster than QA, 1 item will stay here, and QA will have to catch up, and then we'll have to hit a lucky break that development is slow again. But typically, this is something that fills up with a few items, because averages, just because that. So that means that there was 2 days on average of work for every item, but the lead time is almost 5 days. So there you go for your estimates, right? You estimate on effort, and the exact estimate is 2 days of work on average, but on average, you wait 5 days for items to be finished because of this waiting time. Right, let's make the system a bit more interesting. Let's add UX to the mix. But this could be anything, right? So I add UX, development, QA. So on the left side is the work definition, 2 days of work on UX, development, and QA, so 6 in total. And on the right side, it's the team composition. 1 UXer, 1 developer, 1 QAer. And so what happens here? I'm speeding up the thing so you can see patterns emerging. So now we have 200 items that we have to finish. And you see some things appearing here, sometimes here. There's never or seldomly an empty waiting queue. Items are always waiting somewhere. Almost done, there you go. But it's a stable system, you see? So the lines are still parallel because it's 6 days of work on average. But the lead time, more than 12 days, where it was 6 days in actual effort. The rest is just waiting time. Again, your estimates are not correlated to when it will be done. What does management do when they see this? The fact that things take longer than expected. They're angry. That's the first reaction. But what action can they take? Skip QA. I was hoping to hear add people to the process. Well, I'm not hoping to hear that, but I was hoping to hear that from you. But let's change the system slightly so there's an imbalance, right? We all know that UX is easier than development, right? So in total, 6 days of work, but UX is 1 day, development is 3, and QA is 2. So what happens? Very predictably, this is clearly the bottleneck because everything's waiting here, right? So UX is gone. They're home or they're on another project. If something changes now, there's some feedback on the UX, can't do anything. You have to hire new people or take them from another project, which is also a problem. And this is like 1/3 of the whole project. you have a UX person, and then they're gone. So this is an issue in itself. But the lead time. A slight imbalance in the system, we're over 200 days. Right? Why? Because I'm going to point with my mouse now. This thing that was ready at that time had to wait something like 400 days, 400 and something. Oh yeah, there it is, 434 days. But on average, a ticket had to wait 220 days. The very first ticket was almost instantly done, in 6 days, of course. But the last one had to wait a lot. And if we add things to the system while it's working, it's going to get worse. So now, adding people to the process, where do I add someone? Development, right? And so I'm the hotshot manager. I add a developer, and I'm going to add a second developer, so I get twice the output, right? Senior, they're equivalent. They're just pounds right now. So what you see here, 2 developers working in parallel. There's still a bottleneck here. There's still a bottleneck here. But it kind of improves, right? But yet UX is gone. Now the developers are gone, and QA is all alone. And now everything's done. Notice, the previous iteration, we had 650 days to finish everything. Now it's 430. It's not the doubling we would have liked, because we added double the number of developers, but it's better, right? Throughput has increased, but not as much as we would like. 0.3 to 0.46, it's 50% better. Not 2 times, only 50%. But lead time halved. Big win, right? So since adding a developer worked, we're adding a second developer or third one, right? And now we have like 3 people working here, and we see, okay, now there's no bottleneck anymore. This is empty or almost empty. The bottleneck is clearer here, right? So now everyone's gone home and QA works alone again, right? Because we left the bottleneck alone. But the numbers are the same. We added a third developer, and it's exactly the same result as having only 2 developers. But the cost went up, right? The team is more expensive. So what we're going to do is the same thing as the previous one, previous simulation. No, we're not going to add people. We're going to limit work in progress. I did a simulation. Yes, no. So I had that conversation with Jim Copeland, who said, if you have a team of people and you have to work in parallel to keep people working, fire half of them. It's actually or put them on a separate project, right? So now we're limiting work in progress to 10. So between this column and that column, only 10 items can exist at any point in time. And so what happens? Now we get here a line that's parallel. We get a stable system back again. And you're going to see the numbers improve almost instantly. At the beginning of the project, the numbers will be the same at that moment and at that moment, the ones that are up there, except, of course, the number of days you have to finish the work. And so I'm limiting work in progress to 10, and the throughput doesn't change. That's the thing you really have to memorize. Limiting work in progress does not lower your throughput. Limiting the number of stories you do at a certain moment in time does not change your velocity at all. Why? Because the bottleneck is the one defining the speed of the whole process. So we did 10, right? So lead time from 200 for a comparable team, right? So it was 220 here, and now it's 31. Massive improvement. But if I follow Little's law, limiting work in progress to 5 should halve my lead time and keep throughput the same. You remember throughput time, lead time? Lead time is the work in progress. And you can see the numbers instantly. So in the beginning of the project, you see them instantly. It went again from 30 days to 15 days. notice that the actual work is 6 days. So if you had a perfect estimate, it would have still been 6. But the lead time is still 15. It's still very, very bad compared to what you're estimating. So how are we going to improve this? I'd like to improve the throughput now. Any ideas? More people? We did that. Didn't help. Less people. No developers. Excuse me? I didn't get that. Oh, yeah, okay. Yes. Okay, but let's keep the actual work the same and just reorganize people. Dev could do QA, but development is the bottleneck. So we're not going to add work to development. But the reverse can be done, right? A QA person has some kind of development skill, except if they're really point and click kind of QA, but that's not QA, that's zombie work. Yeah. So we're going to assume that we skip the part where QA has to learn development at a certain level. We're going to go straight to the point where QA can do development. And so I'm going to say the QA person, when they have nothing to do, only then, go and help development. So what happens now? Sometimes QA does development, but when they're working on development, work will accumulate here, and so it has still more work there. And when it's done again, it goes back, and there's some kind of a loop there. What happens? Throughput improves, lead time improves. And rather spectacularly. So let's wait for the simulation to end there. There you go. We went from 650 days to 535, 34. For the same work, the same project, we took more than 100 days off the system. Why? Because we had spare capacity. QA was working at 63%. Now it's a 96, give and take, random variation, because I'm not a perfect JavaScript developer. Exactly. JavaScript isn't perfect at all. Right? Yes. No. I nodded no. Did you notice? No. Why? I skipped the part where QA has to learn. So the leveling up, I skipped there. So this is a target to hit. It's not something you're going to have instantly. It's upskilling. So when they have nothing to do, why not watch some plural sites, videos, or collaborating, or helping development and learning by osmosis and increasing the speed bit by bit. But after a while, there's no magic in development, right? I'm not going to go as far as everyone can do it, but if you can do automation in QA, you can probably do development too. And there's always a skill difference. Let's go one step further. Let's go and ask UX, that's working at 39%. If they have nothing to do, please go and help QA. Testing, just testing, not development. Excuse me? We'll get to that. There you go. So sometimes there are 2 QAs working here when there's nothing to do there. And you see that it's stable, but it's going like in waves, right? Because there's like sometimes 2 things here, 2 things there waiting. But even then, lead time improves, throughput improves. And you see it almost instantly. You don't have to wait at the end of the project to see that. And we almost took a whole 100 days from the project again. Yeah. So in the beginning, when UX had something that was done, they would take something new and add to the work in progress, right? Now they're here and there's work here. So they go and work there. And once they're done, and they have nothing to do in QA and there, then only they take something. Yes. But it's a bit of the dynamic, because the maximum was 5 because of the limit. There's still a limit there. Yes. But then we're going to take the suggestion of having only full stack developers, right? We're never going to reach that, by the way. No one is a full stack developer. You can be a full stack developer in the context of one project where you know the security, the database, the backend, the front end, how the testing happens, what the production systems look like, and so on and so on and so on. But you don't know and Mongo deeply, and DynamoDB deeply, and Postgres deeply, and Java, and C# and TypeScript, and front end, and Vue, and React, and Angular, and other. A full stack developer is something you aim for. You try to improve continuously, but you're never there. It's a direction, it's not a place, right? But let's go for full stack developers in this context. Oops, not you. So I added that as a shortcut. Oh, so 3 full stack developers. So now you have like the ideal situation. The developer takes something here, does a bit of UX, puts it here, and then notices there's work there. So it takes his own work, takes his own work, and it's done, right? In a factory, this is the most effective way to work, right? If everyone knows how to use every machine, the work flows very fast. In software, we have some concerns over quality, if you're allowed to test your own work, right? So this is just an ideal state that we could reach. I wouldn't advise to work this way. But it's just to see what the numbers are. Only now is the lead time very close to the actual estimated work. Only now. This is the only situation where estimates actually work. Right? I'm very fond of the idea of doing no estimates in the sense of estimating the work. You do have to estimate, but it's not as precise as we would like to do estimates. I'm not going to go deeper into that one. This might be another session, of course. But this is the simulation I wanted to show you. And we're going straight to the key takeaways. First of all, queues are the killer. Queues with items waiting, backlogs, reviews, ready for QA, ready for deployment, all these ready things where items just wait and there's no one actually working on this. Cycle time goes up, right? Risk goes up. So if something is waiting and is not being used, dependencies that change versions, databases that have to be upgraded, customers changing their minds while you're working at it, or incomplete requirements, right? We talked about that during break. I'm looking, yeah, there you go. Variability, I didn't show that, but in the last simulation where we had full stack developers, it didn't matter what the distribution of work was between UX development and QA. If the total is 6, the outcome will be the same. It's just variability goes down if you have like less queues and more cross-skilled people. Costs go up, not only because things wait, so you put money into them and they're not making any money, but also if things take a long time, so a customer asks for something and in 6 months it's not done yet, they're going to want reporting, right? This is also a cost that gets added to the system. You probably have to hire people to do only the management and the reporting up, so decisions can be made to add developers to the system. Quality goes down. Why does quality go down? No. When you have a lot of queues and they are large, quality goes down. There's, for example, the effect of my work is only taking things from the left column and putting them right, and doing that every day, every week, every month, always. And so motivation goes down. That's also the negative psychological effect. But having that point where I said it was 2 story points, and my PO calculated that means 3 days. And it's already been 5 days. I'm going to feel pressure to deliver, right? I'm going to feel that pressure and I'm going to cut corners. Because if I cannot deliver in the time I estimated, I must be a bad developer. I'm not a bad developer, so I have to deliver quicker, right? This is a loop. The more you're experienced, the more you're going to work against it, but it's still there. It's always there. Yes? I heard, I don't know if you know Alberto Brandolini, the one that coined the event storming practice. He says you can summarize Scrum as how many days is a story point. That's exactly what Scrum is about. So just so you know, story and story points are not in the Scrum guide at all. They don't talk about velocity. They don't talk about burn downs. It's not there. It's been added by the industry, but look up the Scrum guide from Ken Schwaber and Scrum Alliance or scrum.org and so on. Story doesn't appear even there. So look it up. That was cost of queues. And so improving your process, what is free, what is actually guaranteed to help anyway, limiting work in progress. So work in progress throttling improves lead time, but makes bottlenecks visible. We saw that, right? Non-bottleneck skill sets can go and help the process or where the bottleneck is. So you can do swarming, but you have to keep the bottleneck at 100%. So in our systems, there is no one bottleneck. The bottleneck shifts continuously. You just have to watch the queues, and if queues start to fill up, you have to go and help the part that's just behind that queue instead of starting new things. The cheap alternative, which is not free, is cross-skilling. So the QA person learning development, the UX guy learning QA, and so on. This is something that improves the process over time, but asks for an investment. You have to be willing to do that. If you keep everyone in their own skill, you will not reach productivity as fast as you could. And the last resort should be adding people. And then my personal pet peeve, estimates don't work as you think they do because of the waiting queues. And I think this is it. Yes, I don't have a last slide saying thank you, you were awesome, but you were. Thank you.
Are there still some questions for Michel? No, there are not. There aren't. No questions? No online questions? No, unfortunately. Ooh.
I use my own fingers. I think I used no frameworks until about 6 months ago for both the simulation and the workshop, except for Socket.io. And later on, I added Bootstrap because I'm not a UXer and it needs a lot of work on UX side and no one wants to help me.
Is that a bird? Is that a bird?
But it's pure JavaScript. It's not even TypeScript. I would do TypeScript right now, but I didn't know it back then. Any other questions? And I accept pull requests. It's all on GitHub, yeah. Any other questions? So everyone stops doing estimates and everyone starts limiting WIP now? No? And still no questions? Okay, cool, but we'll have a drink.
Well, thank you for inspiring us, Michel. Okay, let's do this. So, thank you for dropping by. We have a gift, a goodie bag from our people at marketing and the developer advocacy team.
Thank you.
Pleasure. I hope you were all inspired, and for the viewers at home, I hope you were inspired as well. Contact Michel if you have any questions about Agile team flows. Be sure to be inspired by his awesome toots. Sorry, I have to have to switch. It's hard being the MC and the DJ. Normally I had people hired to push the buttons, but they unfortunately were all gone. Too expensive. So yeah, this is the true meaning of a full stack developer. All right, so this was the program. We had even this doesn't work. We had a break. And we are going to announce the next edition. Yes, because the next edition of the Coven of Wisdom is being held on the normal first Thursday of the season, the 23rd of March. And it's going to be a special one because we have something lined up with AWS. We're going to have a Coven of Wisdom XL, and it's going to be a workshop where we go through one of AWS's workshop, and it will be hosted by an AWS instructor. So if you're in the neighborhood or want to learn a thing or two about creating a full stack application and what AWS offers for full stack applications in their stack, in their hosting stack, well, please drop by. I think places are limited due to the fact that we have to reorganize this whole room so it could fit desks and stuff. But anyway, I'd like to thank you all for coming. Hope you had a lovely evening, and see you next time.